Let's start with the first lightning talk. So the rules of the lightning talk is that basically you don't do too much of a preparation, and we wanted to kind of incentivize people to bring, like for instance, the thing you mentioned. Whatever you work at your job and you think that it's relatively interesting, or there was something new or something that helped you, some tool, some, I don't know, process, some kind of a new library, or some kind of a problem that you solved recently, and it's generally related to anything cloud native. You can come here and share with us, and it can take 5, 10, 15 minutes, 20, whatever. If you think that is interesting, you don't need to prepare too much. You can just show what you work on and what you found was interesting. That's it. Let me start with one thing, and I tried not to prepare too much. So hopefully that would be in the spirit of this. And we worked recently on a project which was basically a bunch of AWS Lambda functions, so serverless. It was basically a pipeline which grabbed metrics from a gym. So you had those different barbells, dumbbells, and all those different machines, and there were tags that were measuring whether someone is using treadmill, whether someone is using dumbbell, and so on and so on. So these all information were being pushed to the application because there were different kind of sensors. So they measured whether you use, for instance, particular weights, etc. And those measures were sent, those metrics were sent to the application, and we were calculating different things. Basically, what is the utilization on a given thing in a gym? So whether for instance, I don't know, the barbell is a particular barbell is used, or maybe treadmill is used, and people from this gym could figure out, the owners could figure out, okay, we have like only one bench press, and maybe people are using it all the time, so maybe we should buy another one, or maybe we don't need this particular machine because no one is using it. And if you imagine gyms that have like 100 different places, especially in the United States, that might be useful information. So the pipeline was basically basing on those metrics, using AWS Lambda was to figure out what is the utilization. And how you generally deploy your Lambda, and here I have a part of the presentation that I did last year. Basically, if you develop Lambda, for instance, in Java, we are working mostly in Scala these days, so at least part of the company, so we are using Scala. And how you developed Lambda, this is an example of a very simple Lambda, which basically does nothing. It's a hello world, but as you got a piece of code, and what you need to do is to deploy it on AWS. Well, that's something here, and that's some code that doesn't really do anything. It basically replies with input. So this is kind of an echo in Lambda. So what you need to do is to first of all pack everything into UberJar, which is basically a jar with all the classes, with all the dependencies. If you use Scala, you also need to put Scala runtime inside. So we have like 20 megabytes of jar. You need to create this jar. Then you need to upload this to S3 because there is a limitation that you can only have 10 or 20 megabytes. They increased it recently, but only limited amount of size that you can use directly from Lambda. So you usually need to upload to S3. Then you need to have some kind of policies, some kind of role, or everything related to security in AWS infrastructure. Then you need to, the most important thing, even if I have simple Lambda that basically does nothing, like the one that I presented, it at least needs to have some, privileges to write into CloudWatch so we can really figure out that something is happening. Then we need to create function configuration that would grab the bytecode, that would grab our binary from S3, that it would assume the role that we created that uses policy, and then we would be able to run Lambda. So, well, there are many different things that you need to do. You can probably, you need to use AWS CLI, you need to upload your file, you need to create the policy, you can do all those things using like AWS, you can use AWS CLI on Ansible, many different things, right? And at the end you have Lambda that is basically hello world. So that's it. Now, so what we figured out when we started with something like that, you can obviously use many different tools, but what we figured out as we are writing in Scala, so we created a project, and this project is available here, and it's called Zeitgeist. And it basically is composed of a simple library, which is used for the application, and a model for SBT, which is build system like Gradle, but for Scala. So what you do basically is you put your plugins into your configuration, and the whole idea is that whenever you develop something, like I just opened, oh, it's died for some reason. Well, never mind. That's a demo, so it always dies in such situations. So let's start again. Let me try to make it larger. So what do we have is, I'm just disabling tests for now because they will take considerable amount of time. So what you do, the whole process that I described with you could be basically divided in two different stages. Whenever you develop something that is serverless, you have these two things. First is the pieces of code that execute something, and a hell of a lot of different infrastructure that is used, like S3, maybe SQS, maybe SNS, all this glue that joins all those Lambda together. So what we figured out is that maybe instead of writing all those things, what we could do is have a tool in our build chain that would allow to upload the CloudFormation infrastructure. That's one thing. And whenever usually you do that at the beginning, right? And then whenever you change something in infrastructure. And then if you develop something, what you basically do is say, I want to upload my Lambda. That's part of the, that's a plugin for the build tool. And what it will do is that basically it would generate Uber jar, so all the jar with all dependencies, upload the stuff to, that's what I'm doing, upload this thing to S3, and as you can see it's 26 megabytes because it has Scala runtime included in it, everything being packed into a single jar. So it sends it to S3, and when it sends this thing to S3, maybe it will finish at some point, yes, it will say that, look, I see that your Lambda already exists here. So the only thing that it needs to do is, look, my Lambda, I just uploaded new version of jar to pick up this thing and make it work with the code, and that's it. So whenever you all those steps that were related to packing this Uber jar, to sending this to S3, uploading Lambda is basically right now put in the plugin into a single command. Now, if you have something like this, you have a great opportunity right now, because as on the recent reInvent, there was an announcement about new, let's say, features in Lambda, in AWS Lambda. One of them is layers. So when you have layers, you can basically say something like that. I have this one layer which is my reusable piece of code. Think Scala runtime, for instance, or any library, and I have my actual binary. So what you would do, you would create layer once. And this layer would be out of this 26 megabytes, it probably would be around 20 megabytes. And then would be a layer which would be Scala runtime jar. And then you would upload only 6 megabytes, which would be basically your actual application that would automatically have, if this application is configured in such a way that it actually has the layer attached to it, it will actually see the Scala on its class path. So that's one thing. And the other thing is that, as I mentioned, usually writing any application with serverless is a bunch of different functions and lots of infrastructure around it. So what we figured out is that maybe if we create this infrastructure here in a form of the CloudFormation script, what we could also do is maybe use another target in our build system. So we added it to the plugin, and we could also say, look, I want to, right now I changed something. So what I wanted to do is deploy all my stacks, and it would automatically go to a directory. It would also upload the Lambda, because it's sort of a part of the infrastructure too, right? So you have all those things, and one of these part of the infrastructure is Lambda, so it will repeat what it did last time. But it also will take all the cloud stacks that we have, CloudFormation stacks, and it would apply them one after the other. So whenever someone changes it, puts it in a repository, you basically run this build, and you have everything in your build to, in this particular case, it's a SVT. So as you can see right now, you have deploy stacks started, the CloudFormation stacks are actually deployed, and after some time they would finish. So how this looks like basically is that we figured that in SBT, which is a build file for our Scala application, we have something like this, and this thing. So what it does is basically it integrates your build together with the CloudFormation stacks in such a way that, first of all, it says, that one of my projects, I would take upload lambda, and this is basically upload lambda gives you the S3 bucket when it was uploaded. So I can use the target from my build. I can use resolved handler, which I will show you in a moment. Basically, normally you would need to put your entry method to your lambda in a configuration. So to avoid that, what we did is that basically we created a simple annotation that that basically is you annotate your lambda with this thing, and the build tool actually goes through all your source code, figure out if there is annotation. I know that this is my entry point, so you don't need to configure it anymore, any of this configuration. It will automatically be scanned, and the lambda would be created. So how the stacks work is basically we have something like stack execution, and we can say, look, apply this particular template. So this is the first one, roles and keys, and when you applies it, take the results, and you can, as you can see, you can use the results because lambda CloudFormation stacks have both inputs and outputs. So we can set them one after the other and say, look, I want to apply this one, and take the results and apply the next one, and the next one, and the next one. And that's basically what I want to show. It doesn't really work. So it only works in a very simple case. We probably need to this thing what I showed you here works, but it's kind of a clunky. So we need to figure out how to do it better and to apply obviously different levels of different kinds of environments. Usually you would like to have a development environment, maybe UAT environment, maybe testing environment, etc., etc. But the basic of this whole thing works. Basically, you can wrap your function, upload it, change your update your lambda, and that's it. And one thing that we wanted to add is that basically all the project starts usually with some scaffold. Basically, this scaffold is basically something like this. So it is a simple CloudFormation that says, I want to have a bucket. This bucket would need to have a certain level of permissions, and my lambda should look like that. Most of the time, it's very typical. So what we wanted to do is, whenever you start a new project, you just hit the target, generate scaffold for my lambda. It will generate a simple lambda with basic permissions and the basic CloudFormation stack. You go there, you can modify it, you can extend it however you want, and you can from the build tool you can say apply my stack, apply my build. So change my lambda binary, and that's really it. That's what we were thinking about, working on opportunistically during some other parts of the project. For now, it relatively worked well. We had a project which was only Lambda and a couple of SQS, SNSs in between. Any questions? It's black magic.
Is it black magic on Java?
That's actually AWS. It's a CloudFormation.
No,
This is CloudFormation. This one, but that one previously was.
Yes.
Yeah, but that's what people with working on Scala. That's the sad reality of their daily work. So. Now that the good thing about, like you said, that's magic because really Scala seems like a sort of a magic. But the good thing about SBT actually is that SB2 took the philosophy that build tool is actually Scala itself. So it's not like another DSL. If someone writes in Scala, well, that's basically the language that they use for running builds. So that's good because you don't need to learn another thing, and you have quite a lot of expressiveness.
Scala is powerful and they use less resources as far as I know. If you write
Less resources then?
than Java.
Well,
If you know how to manage it.
that is actually a good thing, and I'd say that this question is a perfect transition for a second talk, which is because when we started to doing this, we were thinking like that's a bunch of small lambdas, right? Like 6 of them. They don't do really that much. They grab some information, aggregate them, and put them somewhere else. And we needed to use KMS, Secret Manager. We needed to use RDS. and a bunch of other services, not too many, like maybe 5. And these are really fundamental ones. That's not nothing complicated, right? KMS, things like that, basic services. And we were a hard time fitting our single lambdas within half gigs of memory. Like when we had 384 megabytes of RAM memory for this Java lambda, it was not enough. They failed because out of memory error. So that's the sad reality of writing typical applications as a function as a service in JVM. But there is a light in the tunnel. So I guess that it would be appropriate for Łukasz to present his lightning talk right now. Unless you have any other questions.
No, just my comment was from my friend who is senior Java and Scala developer, and he said in the comparing when my code written in Scala, it consumed less memory, less resources. It's a bit and it shows only huge scale. But in case when you gave for Java-like application 300 megabytes memory,
Yeah, I mean,
it consumed.
traditionally JVM was suited very well for large monoliths.
Yes.
So if you have something like function as a service, which is totally opposite, then it doesn't play very well. But we have Java 11, which has ahead of time compilation. We have GraalVM, and we have Łukasz who would present his talk about another approach. So there's a couple of things happening. I think that this state of affairs would last for another year, maybe, and then there would be a significant change in this area.
And last question is flame for a bird, oil for a bird. Why not Go or Python? Scala.
I don't like personally Python, but I think that Go is a fantastic alternative. Now, if I would to work on this project one more time, we would do it in Go. Definitely. Like we can, and Łukasz would show that you can achieve certain things, but with Go you wouldn't even need to try to achieve certain things. If you think about Go, Go is a language that is good for small projects. It doesn't scale very well, but that's all the fuss. All function as a service, small pieces of software. They don't need to scale everywhere. There are small pieces like thousands of lines of code or something like that. Not even then.
It should be small and fast.
Exactly.
As fast as possible because
Yeah.
you pay for time.
Yeah. All right. So let me disconnect. Thank you. Łukasz?
To jest zasilane? Nie zasilane. HDMI? Stanąć tak z tej strony, w sensie z tej strony. O tak.
Zawsze jest jakiś tam serwer.
Ładne koszulki byli w naprawdę restauracji.
Tak, wiesz. Tak naprawdę... Znaczy, można na tyle ma sens
ustawiłeś, żeby się połączył już?
To znaczy? Co można myśleć?
Nie wiem, czy to się ustawia jakoś połącz z projektorem, czy coś takiego?
No jak go wpinam w domu, czy wpinam go w ten, to działa po prostu autododowo.
To
Nie
dziwne.
wiem, jest taki panel, ale on mu w ogóle nie wykrywa go. W tym momencie.
No to problem. O, czekaj, o,
Co
jest.
się dzieje, ale to nie o to chodziło. Chcę kopnij, wiesz? To nie jest to, co chcemy. Dobra.
Właśnie po to, żebyś ty nie musiał się martwić depresją, tylko żebyś...
Hmm. Czy to w ogóle działa? Nie działa.
Ja bym tam przechował. Ja bym tam sobie swoje wszystkie
Co ciekawe,
Okay. Can anyone see anything?
yes.
Do you recall this? Do you know what it is? In? Looks like Java, right?
Oh yeah, it's Java.
Yeah, it is. It is Java. Okay. Can we begin? Okay, hi, I'm Lucas. I work in Virtus Lab, mainly as a software developer on JVM. I use Scala and Spark for my workday, but I'm a cloud enthusiast and I do a lot of stuff with cloud and Kubernetes. So I'm going to talk about JVM and how well it adapts to cloud world. And I would like to ask you, who uses Java, used Java, or tried using Java in cloud environments? One person.
It's not like you use in production. Try it.
Try, okay. You tried too, right? Oh, okay. Okay, so you're a happy man. Cool. So, Java, in contrast to Go, has quite a big impact on resources, and the biggest problem is that older approach that was used with JVM was that it will be the main server running on the machine, and we just allocate a lot of memory, let the monolith run, and we're happy with the high throughput. So things changed. Now we have cloud, we have containers, we have limited small boxes that we want to replicate. We want to have horizontal replication and horizontal scalability. And Java started to be outdated in this environment, in this cloud setting. So what's happening in JVM world that could happen, that could help with the problems that languages like Go or even Node.js alleviate, that don't have any problems with. So we'll have a small service here. This is an application that will help us store information about our preferred whiskeys. But currently this is just a small Hello World application running with an HTTP server. So this work, yeah, okay, so we have my console here. And first thing we're going to do, this is going to be more of an interactive session. I'm going to code a bit, so demo effects apply. First we're going to build this, and as usual, we're just going to launch this application with Java. So we have some settings visible here that Java was able to read from the system, and it has estimated that the maximum heap size is almost 7 Gs. That's 1/4 of my available memory on this laptop. It has 32 gigs, so it took quite a plenty. So we don't really want this. The usual method to handle this was to just add some flags like XMS, and let's say we want to give 188 gigs max, sorry, XMX. Okay, and now we see that it has some limits for the hip. We can even lower it a bit down. So this was the usual way to limit the memory usage of the JVM. Obviously it works. We can test this. Okay, so what happens when we try and Dockerize this application? We have a target here. I can show you the boring part of the code, but I don't think you would find it really interesting because we have just a Gradle build here, and it has a Docker part, so we can Dockerize it quite quickly. Okay, I'm doing this part in Java and not in Scala because SVT is notoriously slow, so Gradle fits it a bit. And we can see that we now have Docker image of our application. This is the first one pushed 12 seconds ago, and we're going to run this. We will just drop this, just go with, yeah. Okay, so first thing that we see, this is hotspot, as you can see, and it sees exactly the same limits of the memory as it has seen when it was running from the root system and not in a container. That's because JVM disregards cgroups information, at least in JDK 8. This changed a bit in Java 9, and we have now backport that allows us to alleviate this problem. So we are going to switch this a bit. We now have a Docker file that we are going to use, and as you can see, we have added some flags that help us to control how JVM works with resources. So you can see that we are going to unlock experimental VM options and then use cgroup memory limits for HIP and tell JVM also to take everything. So, well, if it sees for 64 megabytes, it should take 64 megabytes. It should take the whole fraction. So again, we're going to Dockerize this, and hopefully we can run this now. And we can pass a flag, like this should work. Okay, so it tells us that it says 28.5 megabytes of HIP memory. That's still hotspot, Oracle hotspot. So let's try and see whether it works. It works. We can try and give it a bit less memory. It should work stably too. But I'm not that sure. So maybe let's just start and try to put some load on it, because why not? Okay, that went well. So with 64 megabytes, HTTP server works in a stable way. So let's try a bit less. 32 megabytes. It starts. That's nice. Okay, let's see what's happened. Well, that was a bit unexpected. Yeah. Oh, okay. So yeah, it died. The Reaper came, killed it. So what's next? So Oracle isn't the only company working on JVMs. IBM is heavily invested in JVM also. And IBM was working on J9 JVM for the bigger part over the last, I think, decade. And lately they have open sourced their JVM. It's called OpenJ9, and we have a way to test how it works. So we have a second Docker file here, which, as you can see, pulls from another base image. And as you can see, we are not really going to give any additional flags. We're not going to hint to the JVM that it's going to run in the container. Let's just change the build a bit. And Dockerize. Okay. So let's try again. 32 max, HTTP server. So we can now see using VM Eclipse OpenJ9. And let's try and see whether this one can handle this. Yeah, apparently it works.
It consumes less memory.
Yeah. So the funny thing here is we haven't really told the JVM that it's going to run in the container, but what IBM did, they concentrated the efforts on new environments that JVMs are going to run in. They have completely redone the memory layouts and redone the garbage collectors, so they are much more efficient. And also, JVM detects that it's running in a SIGREP, so it's running in a container. And it also toggles all the flags that are recommended for running in a container automatically. So we don't have to pass anything that we would have to with Hotspot.
But if we pass something, it will be override. Yes? If we pass some additional flags.
Yeah, we can configure it. Yeah, obviously. There's a very curious setting that I had some fun with. It's called GC Policy Metronome. And that's something that's, I think, a take on Go's garbage collector. It doesn't work like usual garbage collectors for JVM. It works on a tick basis, so there are some, I think, it's a configurable period of time, but I think that basic is around 1 millisecond, ticks of 1 millisecond that do a micro stop the world of the application and drop a bit of garbage out. So it's quite nice. It's optimized for applications that need very, very small pauses. And it's something definitely new, something that doesn't really happen in the world of Hotspot. Okay, so now we have this Hello World application running with 32 max in a JVM, in a container, and it's stable, which is nice. So let's see whether we can do the same thing with a full REST API, which actually does stuff and writes the database. So okay, so stuff changed a bit. We have more dependencies, and we have lots of new stuff here. We have classes that are POJOs. We have a controller that has a lot more roots here. There's some JSON serialization and deserialization going on. This is mounted here, and we have also some data access object here with some queries. So let's start with queryization. So in our, oh yeah, yes, JVM, ADI is dying, okay. So we are going to drop Hotspot for a moment. I can tell you that it will die a lot more time than OpenJ9 due to less, due to eating more memory. But we can try and Dockerize this. Okay, and again. So one thing that I should probably show you is that we have Postgres running in a container, and it behaves like a nice application, eating 10 megs, but this is 31 gigs. Okay, so let's try and run it. So let's start with 64 megabytes before. Okay, and let's see whether it works. No, it doesn't. Why? Oh, nice.
Postgres is down.
No, it's not. That would probably be some networking problem here. Huh. Yeah. Hmm. Okay.
Ah, never mind. Live demo never works. Everyone knows it.
Yeah.
We believe you that it worked before.
Oh, come on. It worked like 2 minutes ago.
Demo got swayed.
Yeah.
Well, it will work again when we finish.
Yeah, I know, but you know, that's
This will not happen if you do straight PHP. Bye everyone.
okay. This doesn't make any sense because it worked.
So what was the result?
The end result is that full-blown application with database access to database works fine under 32 megs of memory in a
32
container.
megs.
Yeah, it's stable, and that happens with OpenJ9.
Now,
So-
what is about the compatibility with the J9 version?
There are very minor differences, and they're working very hard to smooth out any problems that happen. But most of the time, you have no problem running stuff on OpenJ9. So it's very close to having nice runtime for cloud.
So what you're saying, it's possible that you run, for instance, Akka application with Scala runtime and all those things, that it would actually run on the same JVM?
Yeah,
Well, that's-
I've talked on Twitter with people that actually run Akka in OpenJ9, and they wanted to use the next thing I'm going to show, but it doesn't work right now due to reflection. And they are saying that for time being, OpenJ9 solves their problems quite nicely and helps to reduce the load. So statistics that are available on the OpenJ9 website suggest that it is able to reduce the usage of memory by 3/4. So they've been doing tests with Spring Boot, and the application running on OpenJ9 was using 1/4 of the memory that it was using with Hotspot. So the optimization is quite nice.
Yeah, so my next question, my next question was like, have you used it with Spring Boot and Spring Cloud Cookies, like with J9?
Yeah, so this works out of the box with OpenJ9, and it's actually, if you don't really care, if you don't have heavy computation, it makes a lot of sense to move to OpenJ9. It's a bit slower, so all those additional memory optimizations take some toll on CPU, and you can see this when you look on Docker stats that applications running in OpenJ9 take a bit more of CPU, especially those threads. If you connect with Visual VM, you can see that threads of GC are much more active than they were in Hotspot. So Hotspot had this, small ticks of GC, and there's a lot more activity on the threads of GC.
But the algorithms are the same, like you have the same algorithms for GC in J9?
No.
Like
No.
they're totally different, or?
No, the default is generational GC, and they have some additional things that are more similar to G1, and metronome is something completely different. And I think they are going to implement NoOp, just like Java, Epsilon, like Java 9 has. Okay, so there's another player on the market. So Oracle was thinking that Hotspot is nice, but they can do better. And they have started the GraalVM project, which is a compiler. So GraalVM is a compiler that is embedded in JDK and works as a JIT compiler, but it has also additional module that allows it to compile Java and basically any JVM language applications, any language that actually compiles to Java bitcode, which is quite intriguing because there's a second project called Truffle, which allows to compile a lot of languages like Ruby, JavaScript, R, to Java bytecode, and then anything that targets Java bytecode can be compiled to native using GraalVM native image, and that's what we're going to do right now. So we have this application now here. That's the same application you've seen before. Java REST API for storage of whiskeys. And let's try and build it. Yep. No, there's another component. It's called Substrate VM, and it's kind of like JVM, but it's not. It's like runtime mostly Go, so it's embedded in native application. What you get is a static. It doesn't have to be static. You can have shared libraries included in your images. Oh yeah. So that's what happens right now in most of projects, and that's because there's a lot of reflection happening on JVM, and that's something that the runtime can provide, but you cannot really do reflection in a static binary. So I've been tracking progress of GraalVM team since release candidate 1. We are on release candidate 10 currently, and probably 11 is coming in this month. And they did a lot of progress in finding how reflection is used. So they do a lot of static analysis of the code, and they find uses of, for instance, class for name and such. So lots of stuff works. As you can see here, that's usage of some misc unsafe. So there's an API in JVM that allows you to have direct unsafe access to the memory allocated by JVM. And when people are using this, and a lot of projects is using this for performance, that's one of the things that happen. There are some ways to alleviate this problem with shims and stuff that you can provide to the native image tool during compilation to tell it how to treat different branches of code that use stuff like that. But it's quite hard to do this at this point in time.
In this case, instead of memory leaking, we began to write all of not compiling as a C++.
Yeah, kind of. But this kind of problems really happens only with languages that use a lot of reflection, and Java does that. But there's another language on JVM which tends not to use a reflection. So let's see. Okay, so here we have same application. Wait, SBT, yeah, it's dumping project, loading everything. Okay, so here we have the same application, but in Scala instead of Java. And this is one of the black magic stuff that's purely functional Scala, actually. So there are no side effects here. So we have some queries also, and we have some routing also. So we can try and start to build this, at least try. So let's see whether this works. Okay. So I can try and run the compilation again with Scala this time.
So it will create an L binary, right? It will create a binary for you.
Yeah, so as you can see, we are, let me scroll this. We are telling it to build a static binary.
Okay.
So we want to enable HTTP. We want to allow for incomplete class path, so things that cannot be found during image build will crash application in runtime instead of crashing the build due to incomplete graph of classes. And we also want to report unsupported elements. So there are things that Substrate VM cannot handle currently. The list is quite big, but it gets smaller on every release. And you can use this flag to actually run application. It will crash when it gets to the branch of code that isn't supported. So let's see what happens. Yeah, it's going through Scala bitcode, which isn't really compliant, as you can see, but it does stuff, and it actually compiled. So, yay! As you can see, there's stuff missing, and that's caused because we are using Java underneath Scala, and that's Jetty. So, reflection happens. So, I went a bit ahead with this and actually made it work. I hope. And let's try again. This time we can do this proper way. Just SBT Docker everything.
Could you show the size of the binary?
Yeah. I'm just going to show you the size of the real binary, because if GraalVM doesn't see stuff because it doesn't have reflection hints, it then just drops everything because it has quite aggressive dead code elimination, and it doesn't really play nice with stuff that it doesn't fight, it just removes it completely. Okay, so it's not always that slow. It has a server, but I disabled it because server has some bugs apparently, and you can get corrupted state in the server, and then you can't build anything, so who knows.
So what you're saying is that there were reflection problems.
Yeah,
There was such
there's a lot of reflection problems.
small applications.
I can
So
even-
any real world application will have tens of
It's not really that complex, to be honest. You can see reflection config that I had to make this application work. So the less Java you use, and the more Scala code that doesn't use reflection you have, the more safe you are. So, but as you can see, there's a way to declare classes that you want to include with reflection, and that's basically telling GraalVM that those classes will be pulled to the class path via reflective usage. So you can call class for name or something like that. And okay, so success, yeah, it built itself. And we can see that the application here is 32 megs static binary. It's static binary, so it would be a bit smaller if we didn't use static binaries, but then the next trick wouldn't really work. So we can see how it works, and that's something new, I have to say. That's a full, purely functional Scala HTTP server running, like starting immediately. There's basically no startup overhead. And we can, well, give me a break. So, yeah, works. So we can do more stuff, like we can, let's say, favorite whiskey? Okay. Praise be to the demo gods. Glenfiddich, let's say 12, region. It's Highlands too? Or is it Space Side? I think Highlands. What's your rating out of 10? Okay, great. Oh, sorry, not the port that we wanted to use. Okay, so yeah, we have it in our database of whiskeys, and now we can check whether it's there actually. So ID free, right? Yeah, it's in the database. It's in the Postgres. Okay. So this is the one running on the host. So let's see whether we can run in a Docker. So 64 megabytes. That's Scala latest. Okay. Let's see whether it's able to connect to database. It's not. I think that Docker has done something different.
Martin, have you mounted ports?
Yeah. So Docker daemon must have crashed or something because network isn't working. So let's see. Okay. Yeah, that's nice. That's here. Okay. Let's try again. Maybe this will work this one. No.
So in the meantime, I have a question.
Yep.
Have you used it in production yet?
In production.
Yeah.
I'm using it in my private projects, and it's quite stable. I mean, raw VM, native images. It's obviously it has almost no problems with CLI tools, and with this thing called HTTP4S, purely functional Scala HTTP server, it works without any problems. So what I wanted to show really is how far we can go with the.
For us is quite stable. But with Raw VM, I don't think that anyone uses it in production. At least on my account. Apart from very encourage people.
At least second major release.
I think Tracy and other stuff.
It looks really promising, to be honest.
Yeah.
But the same thing is in Java 11, right? Because Java 11 you also have
You can build to native binaries, right?
Yes,
Like-
yes.
Native image, you don't have native image, you have ahead of time compilation. It's a bit different.
I mean,
again.
you could build a binary that includes Java, right?
Not really. You can build not a binary, but you can embed application with JDK. You will still have
Right.
full-blown Java runtime environment.
But you can have like split, like you can get
It's
make
like a
only
single
the
Yeah,
parts of
yeah.
the
There's
JDK.
tool called JAOT and JLink.
Yeah.
So JLink tree shakes your modules. You have to have Java 9 modules first. So it's coming, maybe sometime. Do we have any Docker specialists?
Yeah, but
Because,
I don't know
this
what
stuff
you
works.
did actually. So
Yes.
we
Well, it doesn't really matter, I think, at this point.
Yeah, I have
We believe you.
Docker. Yeah, but the thing is, what I wanted to show that was quite stunning is that native image runs stably in 24 megs of memory.
yeah.
So REST API built in JVM language works with 24 megs.
Together with Scala. Impressive.
but sadly Docker comes to the rescue again. Okay, so that's the network I made for Postgres container. Okay, Postgres is here. We can try and recompile it.
Have you tried turning it off and on again?
That's what is going probably.
Can you show the run command?
No?
Because it went to, it stopped working when you put it in the, when you have put it in the container, right?
Yeah,
So what was the run command? Can you show it?
exactly.
So you're connecting to the database by IP address, right?
I'm connecting to database. So basically, I should be able to resolve hosts inside of the same.
If it's the
Docker
same network, right?
Using the name of the container, right?
If it's the same network.
Yeah. So
Because I've seen 172.18 at some point, and that doesn't seem to indicate the default network. The default is 172.17. That's right. Can you Docker inspect the Postgres port?
Wait, I'm just stupid, I think. DNS. Okay. Let's hope I was just. Yes! Yes!
There we go.
Yes,
So it's used
nice.
to use default Docker.
Yeah.
Yeah.
Okay, so, okay, and it's running in 64 megs of memory. We can check how it behaves inside of the container. We can see that it takes only 20 megs.
Yeah.
So let's squeeze it a bit. Let's see if it's stable at all. Like, maybe it just doesn't work, but it just, it's fine. It's not that fast. And there's a lot of optimizations coming to the native images. And let's try and squeeze it in with the memory. That's a nice thing. And you can see that Visual Control plus C doesn't work. So we have to use Docker kill, and that's called by SVM not passing input to the running process, sadly, yet. I think there's an issue for that on GitHub. Okay, so like I promised, 24 megs.
Because it was run on 19, so why it shouldn't run?
Come on, do it.
Slower, but
Still working. And that's all. Yeah. That's all. Any questions? Any?
So the
additional
regular
questions?
JVM at the beginning, how much memory would it require if you had HTTP4S and the communication with database? Because I think that you didn't show this part. So the real
Yeah.
application and a regular JVM. What was the limit that you did? The minimal
Let's see,
amount of
maybe I
memory?
was just forgetful and forgot to pass network parameter to Docker. Happens. Yeah, check. That was great.
Did you try that?
Well, which one?
Did you try what is the minimal amount of RAM that would be enough for running a regular JVM? Scala
Regular, you
application?
mean, by regular you mean hotspot?
Yes, also,
Well,
yes.
we can try. Press that on. Okay. Scala application.
Yes, Scala with actual database Postgres. So something that normally I would expect would require, I don't know, 200 megabytes or something like that.
In you mean in hotspot, not in OpenJ9? In
Yes.
hotspot, right?
Yes, regular hotspot.
Let's see which options are now being used. OpenJ. Okay. And I think gets confusing a bit after a while. It's not the one that we wanted. We have to go to 4. So is this the one? Yeah. Okay. Oh, no, wait. Stop. Build SBT, and we want to have hotspot. Yep. That's the actual pain point. SBT. So you were asking what was the minimal amount?
Minimal
remember?
amount.
Okay, so let's start with 108. Yeah. Sluggish. So you can see that OpenJ9 starts a lot faster than
Yes,
Hotspot.
yes, yes.
Yeah, so they've been doing a lot of work to optimize. Why?
The port is
Did you expose the port?
Yeah. Yeah, I see the problem. I did change. You know what? This should work if we just do this. Okay, so you can see that Hotspot sees 61 megs of heat. So it took like 60 megs for itself, just for the internal mechanisms. Yeah, the first run is also very nice for Hotspot because it does the JIT compilation. I think it just starts, it doesn't have information to do full JIT, but it takes a lot of time to
Can you
start.
run the test? The performance test?
Yeah.
It's not that bad.
It's fast when it, you know,
Yeah.
there's,
What's the
yeah,
number
you can
you
see it here, like JIT kicked in, and now you can see that everything got a lot faster.
What's the
Lot
memory
faster.
usage right now?
So we can see here, it uses almost all memory available. So now we can put a bit of pressure on it, and let's
Still not
say,
that bad.
okay,
28
okay,
gigabytes. I
let's
would expect
see
more.
96 megabytes. I think that this was the last stable. So 96 max.
Wow.
No. Yeah, it died. You can try. I think it was stable at 96, but it had some problems. I think there's a problem with HTTPS because I think there's a resource leak when Apache Bench fails on a connection, and it happens due to kernel settings. And alleviate it, but on bigger concurrency, there's just not enough handles in kernel, and then there are some problems. Yeah, you can see that now. Oh, yeah, it failed. Okay, that's all. Anything? Any questions?
So I had one stupid question,
Yeah.
but it was related, but it wasn't related exactly to the topic. When you put the JVM under the load, what killed it?
Out of memory.
So it was kernel killed. Okay, okay. I was wondering if it was something
No,
silent
no, it
machine
wasn't a problem with JVM itself. It was just that
just the
secret was
regular.
killing
Yeah,
it.
yeah,
Yeah.
yeah. Thanks.
So I think that for this application, purely functional Scala on OpenG9, which uses a lot more memory due to allocation that happens in functional programming. I think that it was running so within a JVM, not in a native image, under 64 megabytes, so you can shave off 40 megs.
Yeah, that's
why I did it.
pretty. Yeah, that's pretty intense.
Okay.
Impressive.
Thank you.
Thank you.
Thank you.